Welcome. In this short tutorial, we'll set up Magenta RealTime 2 HN, Google's open weights model for real-time music generation HN on an Apple Silicon Mac, generate music on the GPU, and build a little demo app to play with it. 20 slides, a couple of live music samples, let's go. So what is Magenta RealTime 2? It's an open weights music model from Google DeepMind, free for anyone to download. It does real-time, continuous generation, producing audio faster than you can play it back. Everything runs locally on the Apple Silicon GPU, with no cloud required, and you steer it entirely with plain text prompts that describe the style you want. Under the hood, there are three pieces working together. SpectroStream is the audio codec, turning sound into discrete tokens and back into a waveform. MusicCoCa is the style embedder, mapping your text a SCO or an audio clip a show into a shared embedding space. And Depthformer is the generative transformer that predicts the next frame of music, one step at a time. The model is a streaming generator. It produces 25 frames every second, where each frame is a short slice of audio. Every frame is computed on the GPU, which is exactly why Apple Silicon matters here. Because it streams, there is no maximum duration septacker it can run forever. It does that by carrying a state between frames, remembering the recent musical past. First, we pin the toolchain. asdf reads a .tool versions file and locks the exact tools for this one repo. We used Python 3.12.9 as the interpreter and UV.88 as the fast package manager that does everything else. Next, we build the environment. We create a venv with UV, pointed at that asdf Python interpreter. We install the repo in editable mode, so any code change takes effect immediately, and we add the XMLX extra, which pulls in the Apple GPU backend. Now the model weights, which are not bundled in the repo. Running MRT models in it grabs the shared resources, say the codec and the style embedder. Then MRT models download fetches the generation model itself. Everything is saved under the Documents Magenta folder in your home directory. Let's confirm the GPU is live. MLX automatically targets the metal backend, with no configuration needed at all. The default device prints as GPU 0, and a quick matrix multiply confirms everything is verified and running on the GPU. With everything installed, making music is a single command, mrt xmlx generate. You pass a text prompt describing the style you're after. It runs on the GPU and writes a WAV file straight into the outputs folder. We can also batch a whole set at once. A small script batches many prompts in one run, loading the heavy model only a single time. Each clip is encoded straight to MP3 on disk, and on the M4 Max, every clip generates faster than real-time. Now let's actually listen. Here are 8 seconds of warm jazz a mellow piano trio with brushed drums generated entirely on the GPU from a single text prompt. Take a listen. Not everyone wants to live in the terminal, so we built a simple Gradio web app for the demo. You just type a style prompt into the box at the top. Then pick which model size to run the small one or the base one. There are a few controls to play with on the right. A slider sets the clip duration in seconds. You can adjust the temperature and top K to dial randomness up or down, and you can blend in a second prompt to mix two styles into one. Hit generate and a few seconds later the audio appears in the player. It plays back in stereo at 48 kHz. The app reports how many steps per second the GPU sustained, and it shows the real-time factor, proving it ran faster than playback. Here's another one with a completely different vibe. 8 seconds of disco funk, tar, slap bass, and wah guitar from one short prompt. Listen. Let's revisit duration, because this surprises people. In the demo, the slider goes up to 5 minutes. But that's only a UI choice. ACOM streaming generation has no hard limit whatsoever. To go longer, you simply keep passing the state forward, chunk after chunk, indefinitely. Two model sizes shipped today. The 230 million parameter small model runs at about 3.7 times real-time. The 2.4 billion parameter base model runs at about 1.9 times. Both comfortably stream on the M4 Max with 64 gigabytes of memory. How does prompt blending actually work? MusicCoCa embeds each prompt into a vector. We then interpolate between the two vectors to get a hybrid style somewhere in between. Try blending toward a Hans Zimmer racing score for that cinematic, high-octane feel. Let's recap the whole journey. Setup was just 3 tools, asdf, UV, and the MLX backend. The models then run entirely on the Apple GPU. You can generate either from the command line or the Gradio app, and there is no limit on the length of music you create.
If you like this video, please subscribe and share.